Hello everyone, let's try in another example of DFA. What is the question? Design DFA that accepts string containing even number of zeros and odd number of ones over the input alphabet 0, 1. What the question says, we have to design a DFA that will accept the string if it contains even number of zeros, means even times 0, and odd times 1. So let's see some examples first that will help us to understand. For example, 1 0 0 1 1. Will it accept? Let's see. 0 0, it is containing even times, and 1 1 1, it is containing odd times. It means even number of even times 0 and odd times 1, means this string will get accepted. Let's take another example. 1 0 0. Will it accept? 0 0, yes, it is coming even times, and 1 is coming one time, that is odd times. Yes, this will also get accepted. Which type of strings will not get accepted? 1 1 0. Let's see. 0 is coming one time, means odd times, and 1 is coming two times, means even times, means this string will not get accepted. So start solving. Step 1 is our same as the theory, in which you have to define the DFA, its mathematical function. You have to explain the mathematical function. Our step 2 is logic. Our input 0, 1. Okay. Q, capital Q, is a finite set of all the states. In this, QS is our starting state. I will take the convention of the names of the states like that. It will help us further solving the numerical. See, we want even number of zeros and odd number of ones, means even and odd, and we have 0 and 1. In from this we can get 4 different possible combinations: even 0 and odd 0, odd 1, even 0 and even 1, odd 0, even 1, odd 0, odd 1. Now see, even 0, even 1, even 0, odd 1, odd 0, even 1, odd 0, odd 1. These are the 4 possible combinations. So I am taking the convention name as Q E0. E0, what is state? State with string containing even number of zeros and odd number of ones. QEO, even number of zeros and odd number of ones. Same, I will take QEE. It will state with string containing even number of zeros and even number of ones. Same QOE, it will same as string state with string containing odd number of zeros an even number of ones. QoO state with string containing odd number of zeros and odd number of ones. Now see what the question says. It will accept the string if there are even number of zeros and odd number of ones. Even number of zeros and odd number of ones. Therefore, this will our final state. F is final set of final states. So QEO. Okay. Now step 3. Implementation. In DFA, we have to make the state function table. Two inputs 0 1 QS QEO QE QOE QO. Now see, when it will receive only 0 means it is odd number of 0 and no 1 means even number of ones. Therefore it will go to QOE, this state. If it receives 1 means Q as a starting state means empty string. When empty string is 1 means there is odd times 1 and there is no 0 means even times 0. 0 not having 0 means 0 times 0 and 0 is also an even number means 0 times 0. That's why it will go to QEO and this is final state. We will mark this also as final state. Same QEO when it receives 0 means it has even times 0 and odd times 1. After receiving 1 0 it will go to odd times 0 and odd time 1. Thereby QO. Same when it is having even times 0 and odd times 1, when it receives 1 again it will become even times 0 only and even time 1. Same for even times 0, when it receives 1 0 means 0 again it will become odd times 0 and even times 1. Same for this, it will become even times 0 odd times 1 and this is a final state, so we will mark it with star. For QOE odd times, when it will receive 0 it will become even times QEE and it will become QOO. When Q00 sorry 0 O, when QO, when there are odd times 0 a 0 will come, then it will become even time, so QEO. This is a final state. We will mark it with star and this will become OE. Based on this we will make our transition diagram. I am making the transition diagram here only. Step 4, transition diagram. Now see, QS is our starting state. So since there are 4 states, I am drawing this QS here. It is a starting state. I am marking it with the star. Yes. Now I am making these 4 states here: Q, EO, QEE, QOE, QO. Circle this all states. This is a final state. We will give 2 circles. When QS receives 0, OE. QS receives 0, it is going to OE. When QS receives 1, it is going to EO. When QEO receives 0 0, it is going to QO. When it receives 1, it is going to QE. Same now QE. When it receives 0, it is going to QOE. When QE receives 1, it is going to QEO. Same QOE receives 0, it is going to QE. QOE receives 1, is going to QO. Same QO receives 0, it is going to EO. And this is 1, it is going to OE. This is our transition diagram. Now step 5. Let's solve an example. Let's take an example QS 1001100. When QS receives 1, it goes to QEO 001100. When QEO receives 0, it goes to O 01100. When QO receives 0, it goes to QE0 1100. When QE0 receives 1, it goes to QE 100. When QE receives 1, it goes to QEO 00. When QEO receives 0, it goes to Q00 0. When QO receives 0, it goes to QEO. Therefore, it is accepting. Actually, this is EO, even and odd, and this is our final step. That's why we are accepting this. Let's take an example of rejection also. QS 10001, QEO 0001. Same, when QEO receives 0, it goes to QO 001. When QO receives 0, it goes to EO 01. When EO receives 0, it goes to QO 1. When QO receives 1, it goes to QOE. Since QOE is not a final step, it is rejecting. As you all can see, it contains odd number of zeros. That's why it is rejecting. You can cross check this answer by see odd number of zeros. Yes, it is going to odd number of zeros. QO means odd number of zeros, and it has even number of ones. Yes, it is going to the state QOE which contains even number of ones, means our solving is correct.